Everyone, welcome to Cassandra Lunch number 117. We'll go ahead and give everyone a couple minutes to file in and we'll get started soon shortly. Alrighty, let's go ahead and cut the music. Hey everyone, welcome to Cassandra Lunch number 117. Today's talk is going to be 5 disciplines of a Cassandra expert. Today's guest speaker is going to be Hayato Shimizu, who is a co-founder of AxonOps. Coordinators for this event are Rahul and myself. If you are interested in giving a talk here at Cassandra Lunch or our sister lunch, Data Engineers Lunch, feel free to reach out to me. My email is listed below. Also, if you're interested in sponsoring, feel free to reach out to me as well. We are a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, or sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC, so you can find out more about all the other organizations that fall under the umbrella of Data Community DC at datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem, whether that is open source Cassandra, managed Cassandra, enterprise Cassandra, or variants such as DataStax, Scylla, Yugabyte, Cosmos DB, key spaces, etc., as well as things in the ecosystem such as Kafka, Spark, Airflow, etc. If anyone's new here, say hi, hello in the YouTube chat. Group rules, if you have a question, feel free to ask it in the YouTube chat. We'll be shepherding questions for Hayato here on the Zoom, but feel free to drop comments as you have them and questions as you have them. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. GW University helps provide venue space when we have in-person events. We also have some organizational institutional sponsors. If anyone has any jobs that they're offering or is looking for a job, feel free to drop links in the YouTube chat, as well as any meetups, hackathons, conferences, or classes they would like to promote. Feel free to drop those in the chat as well. Anant is hiring full-time, part-time positions, data platform operators, engineers, or architects. You can find out more at careers.anant.us. Upcoming events. You can check out our events page, as well as all of these videos for Cassandra.Lunch are available on our YouTube channel, youtube.com/AnantCorp. So don't forget to like and subscribe while you're here. We have Cassandra Lunches starting from Cassandra Lunch number 10 all the way till today, Cassandra Lunch 117. Cassandra.Link should be no more resource for all things Cassandra. This is a hand-curated site by the team here at Anant. You can find resources, articles, videos, news feeds, as well as anything in the context of Cassandra. We've aggregated it to Cassandra.Link. We've also released our 9th free Apache Cassandra runbook. This one covers getting started with Cassandra troubleshooting, as well as some tips and tricks and some commands you can run, as well as starting, restarting services. If you're running your node tool and you node your nodes down, we'll show you how to get that back up and running. And we'll drop that link in the YouTube chat so you can get it for free. And with that, we'll go ahead and pass it over to our speaker for today, Hayato.
Hey everyone, let me share my screen. 2 seconds. Right, let's get the slide started. Let me know when you can see the screen.
Yep.
Great stuff. Yep. So my name is Hayato Shimizu. I'm a co-founder of 2 companies, Digitalis and AxonOps. Digitalis is a service company, predominantly kind of a service in the Cassandra Kafka market. We've got AxonOps, a company that we set up. It's a tools company, so we've created a Cassandra operations tool. And today I'm going to be talking about top 5 disciplines of a Cassandra expert. Just a quick intro of myself. So who am I? Well, I started as a C++, Perl developer early in my career, but moved on to DevOps before it was called DevOps terminology in the past. Started testing Cassandra in 2008 at a company called Sky, and then we managed to productionize in 2011, fairly early on. We absolutely loved it, and then actually joined DataStax in 2013 as a solutions architect, but left in 2016 to start my own Cassandra consulting and managed services company in the UK. And then recently launched AxonOps as a SaaS tool for managing Cassandra operations. So that's just a bit of background about myself. So as Cassandra audience here probably don't need no introductions, but you know, it's been used by many of the popular internet applications out there. It'd be hard to miss using Cassandra somewhere in the background when you're using your mobile phone applications or any kind of web interactions you have. You're probably interacting with Cassandra in the back end on the database side of things, but it's quite transparent to most users out there. So, you know, as with any kind of you know, great applications, there are these engineers in the background working away, making sure that the system's up and running. These Cassandra engineers have to make sure that you know, the platform stays up and running to service the users of the platforms, right? So those are the kind of you know, the heroes in the background that most people don't know anything about. But what do these kind of heroes do, and what are the kind of top 5 disciplines of the Cassandra engineers? And I thought about this as to how, you know, what the top 5 are. There are so many things that you know, Cassandra engineers need to do, but I've kind of narrowed it down to a few of those and created a list for you guys today. So I think I'll start with the first one, really, kind of, you know, starting with the basic of, you know, the Cassandra, one of the disciplines is really around the hardware selection. So, you know, selecting the right hardware for Cassandra is really important when you're running this into, you know, at scale as well. You know, you've got to think, you know, that Cassandra is a database. Yeah, it will hammer your hardware a lot. The CPU, the memory, disk, and network. You know, as the users come onto the platform and they'll be interacting with your database, the hardware is going to be hit. So you've got to select them correctly. I mean, even in the cloud as well, you've got a plethora of different types of instances that you can purchase, and you've got to think about what are the best ones for your workload, especially for Cassandra. So in terms of the first thing about the hardware is the CPU. It kind of has a linear relationship to the transactions you're going to get. So more CPU you're going to give it, more throughput you're going to get out of the platform. But you know, CPU is being used for many other kind of background processes in Cassandra, including things like compaction. I mean, the Cassandra is quite intelligent in that, you know, though these kind of background tasks are set to lower priority to the queries. But yeah, you still have to think about the CPU consumption of these background processes. I mean, streaming is another one that takes a lot of CPU hit on the receiving side of things. 4.0 has made this better, but not if you have SSL enabled on the Cassandra cluster, which I'll talk about in a bit. Memory, again, very, very important for databases, especially when you want to have good performance out of them. So, you know, JVM is going to use the heap in Cassandra. There's a lot of off-heap usage as well. And finally, the most important thing about the memory with Cassandra is that it uses all of it through page caching. So all of your queries will be faster. So more memory you give it, generally the better read performance you're going to get out of them as well. Okay. Storage. Yeah, this is very, very important for Cassandra because it's a database. Database stores data on disk. So if you want to get good performance out of your queries, then you're going to need fast disks. In the olden days of rotational disk, you combined them and made them to RAID to try and get as many IOPS as possible. But these days, you've got these NVMe drives, SSD drives that are pretty damn fast. You know, we get over 100,000 IOPS, no problems out of these babies. And yeah, the cloud. If you're deploying Cassandra into the cloud, then you may have deployed this with remote volumes. Like ESBs on AWS, for example. They're generally very expensive and slow compared to the local NVMe drives, SSDs. If you do any kind of performance benchmarking of the storage, then the AWS i3 instance types of the local SSDs give you very, very fast performance disks. Remote volumes are much slower, although they do give you a bit more flexibility. So it's really kind of down to what you want. Yeah, you don't do spinning disks these days. SSDs are kind of requirements really for Cassandra, high throughput types of databases there. And yeah, IOPS definitely is a massive considerations. I mean, directly correlates to the number of queries, transactions you do against the database, right? So if you're doing lots of reads, then you're going to kind of need that IOPS from the disks. And of course, the throughput is important as well, because you are doing the various compaction, which scans your data, and that's really high throughput reads and writes you're going to do against your disk. So you do need those performance. As I said, NVMe drives will give you that. But if you have to do these, EBS drives or remote storage in the cloud, then do think about the IOPS and throughput side of things. They tend to have the relationship between how many gigabytes you provision in the remote disks as to how many IOPS you're going to get. So that's something to think about. There are other kind of volume types that give you expensive IOPS, provisioned IOPS as well. Okay, so second tip here, so discipline, so tuning. So tuning is really, really, really important when you want to get your Cassandra to perform. So the Cassandra engineers generally kind of tune the servers well. There's nothing worse than listening to badly tuned violin, right? And it's the same with Cassandra. So, I mean, one of the things you have to consider is the OS. First, right? Linux OS, when you spin it up, it's not tuned for Cassandra. It's not tuned for databases in general. It's tuned for just general workload. But there are many, many parameters in the kernel and configurations that you can set on the storage and so on. Do go through some of the documentations that's come out of DataStax, and that came. You can look at Google. Production settings for Cassandra. And there are a couple of great articles, documentations in DataStax website. So do go through those. It's been produced by someone called Al Toby or Amy Toby, So she's produced amazing articles around performance tunings of Linux servers for Cassandra. And then, the slides repeated. The JVM tuning. So this is something that these days it's lots easier. In the days of CMS, it was very, very difficult. But CMS is now kind of going to be deprecated in the future. When G1 GC came out, we were clapping. Made the whole kind of GC much easier to tune. So that was great. But do kind of consider, and I'm saying that testing out various heap sizes for your G1, GC. They do kind of affect your performance. Really depends on your workload, but it's worth having a play with the sizes. Now, don't take up the entire memory space with your with heap. So if you have like a machine with a 32 gigabytes, don't give it like 30 gigs of heap, because actually Cassandra doesn't need all of the memory to be assigned to the heap. As I said, there's a page caching that goes on as well. So it's there's optimum tuning that you need to do. There's a lot of articles around heap size for Cassandra. Just Google it and have a read through some of the articles. So more recently, Shenandoah garbage collection type has come out. It's developed by Red Hat folks, I believe, and it's actually been very successful for Cassandra workload. So there's been some benchmarks around that Shenandoah GC, and seems to provide a good balance of throughput and latencies around the GC as well. So do have a play. Azul Zulu JDK has got it embedded into their version of JDK 8 onwards. So if you're still on JDK 8 with Cassandra 3.0, 3.11, etc., I would recommend playing with the Azul Zulu JDK. And there are things like disablement of transparent huge pages, and there are many tunings that you should do for Java. And then there's the Cassandra tuning, and that I've seen so many Cassandra deployments out there without making any kind of considerations around tuning. And I'll kind of list 3 obvious tuning parameters in Cassandra.yaml file. Now, there are parameters called concurrent reads, concurrent writes, and native transport max threads. These are thread pools defined in Cassandra, and they're 32 for reads and writes, and 128 are okay for development environment. But when you're provisioning a machine with, say, 16 CPU cores, and you can crank these up. If you don't crank these up, it doesn't matter how much load you try to put onto Cassandra, because of the thread pool sizes, you leverage all of your CPU capacity that you've got. So do have a play with those. But there are many other parameters in Cassandra. Just, as a Cassandra engineer, do go through some documentations on what they do, and then have an experiment of changing them, see what happens. That's how you learn how Cassandra behaves, right? So, and then the third discipline I want to talk about today is around the security. Now, again, I do look at a lot of Cassandra clusters out there. Again, default configurations with absolutely no security. Anyone can access them. And there are so many Cassandra clusters out there that are exposed to the public internet with no username and passwords as well. So do secure your Cassandra clusters. It's a database. It stores important data in there. Don't let anyone else access it if they don't need to access it. So there are 3 topics around the security. So user access and role-based access control audits. I want to talk about. The other one is encryption, data at rest, data in flight, and then finally the JMX security. So in terms of the user access, so user access, right? Anything from your platform access into Linux user access, do implement some access management solution. Don't let any unscrupulous people access your Linux servers. And then run no-till commands and things like that. Yeah. So implement secure access solution into Linux. The other one is Cassandra access. By default, allow all authenticator is enabled, which means many people just use the default configurations, and then there's absolutely no security on the CQL port. So anyone can run the SQL queries against that port. They can access that port, right? So do update this to password authenticator and enable users and passwords for accessing Cassandra. One thing to remember is that the authorization aspect of it, so role-based access control, also needs to be changed from allow all authorizers to Cassandra authorizer. So do change these as soon as you have your Cassandra deployed. Okay, so Cassandra roles, yeah. So once you enable the Cassandra authorizer, then you're going to have to define some roles. So do think about the principle of least privilege. So whether it's application access or user access, give them the minimum amount of access they need. Now, allow all authenticate allows you to do everything as nobody. So once you enable the password authentication and authorization, do set up some roles and then don't give them everything. Some applications only need to write to a table. Those applications should only have access privileges to a specific table to write, and others only need to read. So give them read-only access. Okay. So audits. So Cassandra audit logging was always missing. It was present in DSE for a long time, but finally got introduced the open source in version 4.0, Cassandra 1215, Jira Ticket 1215. Brilliant. So it's a great feature, especially in enterprises. Enterprise been begging to have this feature, and it's really important that people need to know who's accessing Cassandra and what they did. So yeah, but do read the documentation. It's not like a binary enable it and that's it. You do need to understand what the audit login feature does, which can become very verbose. So yeah, make sure that you read the documentation and enable it wisely. Now, do put the audit logs on a different volume from Cassandra data volume, right? So I've seen it quite a few times that the logs got so large and they didn't get rotated out and then filled up the disk volume and then killed Cassandra because the disk got full. So you don't want the audit logs to be shutting your database down. The other one is encryption. So data in-flight encryption. So my recommendation is always enable it. Now, the reason being, your application code, when you're when they're accessing Cassandra, you do it slightly differently when the SSL is enabled. So if you've got different code paths of development and production environments where the development is non-encrypted and production is encrypted, then it's not great. So make sure that you've got SSL enabled or TLS enabled in all environments, so that the applications can have a consistency as to how they're accessing the Cassandra database. Now TLS 1.2 is supported, but 1.3 is not yet. I think it requires a Netty library upgrade, so there's a ticket for that in Jira. But yeah, do enable TLS 1.2, and generating keys and certificates and things like that. It can be bamboozling to some people, but it's kind of important that you protect the databases with encryption these days. I mean, I remember when I first started my career, where I was telnetting into Linux servers, no encryption. Now SSH is the default. I wouldn't even think about not using SSH for accessing Linux servers, right? And it's the same with the databases. Do use TLS to access databases, yeah. Data at rest encryption. This is kind of easy in the cloud, right? There's a tick box, say, and encrypt. Of course, they use their kind of keys in the cloud, but you can, bring your own keys as well. So yeah, just enable it, right? And if you're using your own Cassandra servers on bare metal or virtual machines, then yeah, do kind of use something like a Lux or and decrypt in Linux, and then store the keys outside of the box somewhere else on something like HashiCorp Vault. So, but yeah, just encrypt your data. Finally, the security JM export. So JM export, it allows you to access all the internal MBeans, and we can do a lot with them in Cassandra. You can, it can be highly damaging operations, right? So you do want to protect it somehow. Although, JM exports are bound to the local host by default, so it's not so bad that they're not exposed to the entire world. But yeah, I mean, it's kind of, should be protected if you are wanting to secure databases. So Cassandra and JMX, it's got clever stuff in there. So the JMX can be protected using the Cassandra users and roles. So there's a documentation on the Cassandra docs website on how to enable this JMX authentication. So yeah, just have a read through them. It's not that hard, right? And then you can protect your JMX. So when you're running your node tool commands, you do have to provide your username and password to access it. All right, so that's security for you. And number 4, the observability. So you really need to understand how Cassandra is performing, what the platform's doing. When you're looking after the Cassandra nodes, you need to understand, whether your queries are running slow. I mean, that's what the most important thing, right? Are my reads slow or write slow? Are they fast? What's throughput? Are they keeping up? Yeah, so you've got the kind of performance metrics that shows you that. And there are plenty of other information, things like logs, Cassandra logs as well. Something that you need to kind of, be having a dashboard of is something of the availability. So you want to have a dashboard, say everything's green, the RAG status, and then say, hey, my cluster's good. Tracing is part of that kind of observability. I'm not going to talk about it today. This is a big, deep topic. So, and performance-wise, you need to know how the system performance is doing. So CPU utilization, the memory, the JVM, the storage network, the IOPS figures, or the throughput on the disks, or the disk latencies. Are my CPU being packed 100%, or what's happening? JVM, you've got the heap, the young and old gen, you've got the GC times, GC count, many other kind of metrics available as well. You want to have a dashboard telling you how your Java's doing, right? Cassandra outputs a lot of metrics, right? Tens or thousands of metrics straight out of the box, and then if you keep adding more tables to it, it outputs more metrics. So you can overwhelm the collection of metrics, but it's handy to have all of these metrics collected and then dashboarded. I mean, these are some of the kind of key metrics like coordinator, the latency, throughput, timeouts, and they come out in different percentiles. So if you want to know the critical timeouts, or the latencies, like what's my 99.9 percentile latency of the coordinators, you've got to want to know the table level replica read and write latencies and throughput. Again, they come out in different percentiles as well, so you need to have the dashboard that allows you to navigate through that. Things like SS tables, how many SS tables are being scanned per query, how many tombstones are scanned in each query, what are the partition sizes, all of these metrics are available. Again, compactions, there's a lot of metrics around compactions, thread pools, many thread pools, but read and write thread pools are kind of important. Are they backing up? So that, if you start seeing blocked threads, then you need to understand why that is, right? There's a bit of cache and dropped messages metrics as well. You don't want dropped messages in Cassandra, so you need to know about them and understand why they're happening. And these dashboards will give you the reasons. If you entropy, so hinted handoff, read pairs, various anti-entropy threads and things like that. So there's a lot of kind of metrics that give you how your cluster is performing. But when you do have issues, these dashboards will give you great hints as to why there are problems going on. You've got like free tools like Grafana, Prometheus, and JMX Exporter, and Node Exporter, and things like that. And paid for products like Datadog. AxonOps is a monitoring dashboarding tool that's been developed specifically for Cassandra. For its, do check it out as well. It's if you've got a free license in there on the SaaS for a certain number of nodes. The logs, yeah, again, logs. Collections, so collect your logs and make them searchable, and then make them, create dashboards out of them. And there's system.log from Cassandra. There's debug.log if you enable it, and then also the audit log. So do collect those and then make them searchable. You've got tools like Elk and commercial tools like Similarlogic and logs.io. Again, AxonOps will collect the logs for you. So there's a single agent that collects the metrics and logs and then pushes it up to the service. So worth checking that out. Availability. So you want to know, how your clusters perform. Are all the nodes up and running? Are the CQL ports available? Storage ports available? Can I run CQL query against them? Are they? Can I run simple queries like select a particular partition, or are my processes up and running on the servers? Are my SSL certificates about to expire? Those kind of information you want to know, in a dashboard. So do create a dashboard. Again, AxonOps does provide that kind of dashboarding for you, so you can immediately see where you may be having problems. But yeah, knowing this kind of that your cluster's all green. Gives you that nice warm fuzzy feeling on the cluster. But when there are problems, boom, you know exactly where the problems are. And then the fifth discipline, disaster recovery. So again, I've seen many clusters, Cassandra clusters out there, and they are not being backed up or restored. No restoration process. One of the kind of arguments is that, yeah, Cassandra replicates data across multiple data centers, so we don't need to back it up. But I've had a couple of instances where this customer came to me and said, "Oh my gosh, I've just ran the development cleanup script against production and deleted all my data and didn't do any backups. What do we do?" And I was like, well, we deleted the data, so it's gone. There's no backup. Luckily, I was able to use kind of these the file recovery tools from their disks and recover as much stable files as from the disks. I told them to shut down the Cassandra nodes, so there were no writes going on. And yeah, we were able to recover some of the files, but yeah, backups are important. Human errors can happen, right? And this is even like the large organizations like AWS. Human errors have wiped out some data and things like that. So yeah, backups are very, very important. So you've got Cassandra snapshots, commit log archiving. But you do need to push them up to remote storage outside of the Cassandra servers themselves. So yeah, do implement some kind of backup solution. There are free tools like Medusa out there, so have a look at those. Again, AxonOps provides an integrated approach to backup and restore. in terms of the backups, do test restoring them and making sure, that you can restore from the backups in the in case of a disaster. And understand the process and document the process. When you're in a panic in the middle of the night, when you lose data in Cassandra and then you need to recover from backups, you don't want to kind of be thinking, right, what are the steps? Have the steps documented and then follow the steps. Have the steps tested so that you feel comfortable in the restoration process. The other things that you need to think about for the business perspective is the recovery point objective and recovery time objective, right? So, you need to tell business, okay, if the disaster happens, where can you revert back to? And then how long would it take to do the recovery work? So that's a recovery time objective. Have them defined by a business and then implement it accordingly. All right, so those are the 5 top disciplines of Cassandra engineers. There are many others that I just don't have time to talk about in a short session, but here we are. We have a blog on our AxonOps.com website that goes through these in more detail. So thank you for listening, and I'm happy to take questions or answers at this point.
Yep, go ahead and feel free to drop any questions or comments in the YouTube chat, and we'll get them answered by Hayato. Also, if you are interested in Cassandra query tracing, we also have a Cassandra Lunch for that. So you can check out our YouTube channel and the Cassandra Lunch playlist, and you'll be able to find full query logging, as well as topics covered with tracing, as well as things that Hayato mentioned with security. Deepan has given some talks related to SSL on open source Cassandra. So if you're interested in those, you can definitely check those out. But it doesn't look like there's any questions for you, Hayato. So we do want to say thank you for giving this talk. I think this is super helpful for people who are getting started in Cassandra, but also who are kind of already getting their feet wet with Cassandra. I think this is a really good way for people to focus their knowledge and their training and what to get right for working with Cassandra. So definitely thank you again for giving this great talk. Actually, it does look like there's a question in the YouTube chat. What's the most common non-ops issue that you see rise up in things such as logs or metrics?
Okay. So one of the things that's kind of interesting in the, okay, let's pick one in the logs, right, is the slow queries. So there's a parameter in Cassandra YAML to enable slow queries. So if the queries are taking over a certain amount of time, then log what those queries are. So that's kind of interesting for the application developers as well. And they can correlate, okay, the API response time is taking time. But there's a blip here. Why was that? And it could be related to a bad query, or potentially kind of maybe you have lots of tombstones, and then there are logs around the tombstones as well. If the number of tombstones scanned over goes a certain threshold, you'll get to know about it, which means you might be doing quite a lot of deletions in your applications, and then that can affect your performance of your application side of things. So yeah, they're in your logs.
Yep. Another question. Could you talk on dropped messages? When hinted handoffs happen, are we expected to clear that?
So if the drops happen, then that means there's something bad going on in terms of your cluster. Perhaps that your cluster was really busy, and then the CPU was being hit very hard, for example, and some of the kind of messages like could get dropped. Now, there's not a huge amount you can do at this point about the dropped messages, but the hints will stream until completion, and then they get deleted. You should be okay in terms of the hint delivery, in that if you've got the hinted handle files on the file system, because one of the nodes went down. If you do see drop messages, I think it should be okay.
Great. And yeah, feel free to drop any more questions if you have them. But yeah, definitely shout out to AxonOps. They have a free tier, so you can check it out. If you want to give a quick little intro on that as well, Hayato, feel free.
Yeah, absolutely. So AxonOps is a SaaS tool to manage your operational aspect of your Cassandra clusters, right? So it does the monitoring, alerting. It will integrate with the Slack or the Teams or the PagerDuty, and you can define your alerting rules very easily based on your query performance or anything else you like in the dashboards. The dashboards are pre-built for you for Cassandra, so it's got all of the kind of performance metrics that you want to look at out of the box. There's nothing else for you to configure apart from installing the agents and starting up your Cassandra cluster, and you'll immediately get the dashboards. There's only one agent installed on the for AxonOps. It will do to collect the logs and metrics from your Cassandra nodes and then make them available on the dashboards. But it's an outbound WebSocket connection from the agents to AxonOps service, and it's a bi-directional protocol. So the AxonOps service can actually manage your repairs for you and backups for you from the SaaS. So repairs, I've got a logic on the server side to slow down when your cluster's busy, and then speed up back up when the cluster becomes less busy. So it's got this dynamically slowing and going slow down mechanism, and then catches up with a repairs when the resources become available. So and all you need to do is just flick the switch on, and you'll start repairing your Cassandra clusters. And then it's got a backup and restore mechanisms, so you can back up to your S3 or the GCS, and there are a number of backup endpoints, and it will do the differential backups rather than the full snapshot backup. So it's a very efficient way of backing up your Cassandra clusters.
Great. Yep. Thank you for that. And again, AxonOps has a free tier, so you can check it out at AxonOps.com. And again, we would like to thank Hayato for giving this great talk. As Rahul mentioned in the YouTube chat, it's a very succinct list of skills. This is a great outline for folks to dive deeper on. So love to see more people getting their hands dirty with Cassandra. And this would be a great starting point for building their knowledge. And with that, we'll go ahead and wrap up for today's Cassandra Lunch. Thank you again, Hayato, for joining us. And we would love to have you back. And we will see everyone next week. Take care.
Thank you for having me. Cheers.